welcome to lesson 19 on weighted averages. I think if you follow along, you'll find this section not that difficult. It just, you just have to be a little careful, but I think you'll be fine. So recall that from the data we worked on back in lesson 8, where we had number of pets and number of households. So we would read this as 10 households in the survey had 0 pets, okay? 12 households had 1 pet, etc. So we're gonna find the average number of pets per household. That's our goal, right? So how many households were there in this study? So I'm gonna add up the households here, plus, right? So we got 10 plus 12 plus etc. And when I added all those up, I got 56. Now, how many total pets are there in this study? Some students, this is where you make a mistake, some students are tempted to go here and say, well, the total amount of pets is, add these up. But that would be a very critical error. Because, for instance, 10 households had no pets. So that would be 0 pets to start with. I'm going to add up the total amount of pets. I'm going to add to that 12 here. 12 households had 1 pet each. So that would be 12 more. That would be 12 pets. And then I'm going to add these pets here. I have 10 households with 2 pets in each household. So that's 20 pets. And now here I have 10 households with 3 pets in each household. So that would be 3 times 10, or 30 pets. And now I'm going to keep on adding these up. We can compare answers. So fast forwarding, I think you can see that there's 150 total pets. At least that's what I got. And I double checked, but you can always make an error, right? So now I want to know the average number of pets per 1 household is really what they're asking, right? So this is going to be 150 total pets per 56 total households. So I'm just going to divide that, and I get 2.68. So that is the average number of pets per household. Okay, so we are now looking at D here. It says, in this study, which is the one above, which we've been working with, what is the ratio of households with no pets to, I'm going to put a colon there, right? Households with 2 pets each. So there are 10 households with 0 pets, and there are 10 households with 1 pet. So the ratio would be 1 to 1. You might want to put it on pause and think about how you would write that as a sentence. So there's the sentence you might want to consider. There's a lot of ways to write it, but I wrote it: for every household with no pets, there is a household with 2 pets. Okay, so let's look at number E. In this study, what is the ratio of households with no pets to total number of households? So there is 10 households with no pets, so that would be 10, 2, and if you go back to the previous page, our total number of households is 56. Or you can write it 10 to 56. You could reduce it, didn't say to. That would be 28 divided by 2, 5 to 28. Same ratio. This one's a little easier to work with, so we'll use that one in a sentence. So what sentence would you write using this as your ratio? Well, have you thought about it? How about for every 28 households, there are 5 households with no pets? Or you could say for every 56 households, there are 10 households with no pets. And let's put that up. So voila, that's one way of writing it. Okay, now we'll go on to our last question. It says, assuming that the ratios remain as they are in the study, how many households of 4 pets each would you expect to have if you surveyed or studied 1,054 households? That's a good question. It really gets at, do you understand what a ratio and a proportion are? Okay, so we're going to assume the ratio is as it is in the study. So 4 pets, there's 2 households with 4 pets. So the ratio of households with 4 pets to total households is 2 to 56. I can make it 1 to 28, but we'll leave it like that. So that ratio is going to equal the same, an equivalent ratio if we surveyed 101,054 households. So hopefully you can figure this out, right? Hopefully you can figure the whole thing out. But I'm going to cross multiply and divide. And I get 37.6. And it's hard to have 0.6 of a household. But you can have it in the ratio, but you can't have it in real life, which I would round to 38. So these are pretty equivalent, right? This ratio here is equivalent to this ratio here, and I solved it using a proportion. So we're going to do problem 2 now, weight averages. It says 1/5 of the 20 students in the class. So the class has 20 students, and 1/5 of them scored an 80 on a test. And all the remaining students scored 100. What was the average test score for the class? And here is the classic error when students read these kind of problems. Number 1 error is students do this. 80 plus 100 divided by 2. That is the kiss of death with weight averages. So you don't want to do that. You got to be really careful what's going on here. So first of all, I'm going to find 1/5 of the class. 1/5 of 20 means 1/5 times 20. That's the same thing as 20 divided by 5, which is 4 students. So you had 4 students get an 80. And being that there's 20 students in the class, you had 16 students left that got 100. So now the way you could do this is you could go 80 plus 80 plus 80 plus 80. There's the 4 80s from those 4 students. And then you could start adding 116 times. I went through this a few lessons ago as a preview of what this was. So that's laborious and it'll work, but who wants to do that? But a quicker way is to go 4 times 80 plus 16 times 100 divided by the 20 students. And we'll put that in our calculators. And I get 1920 divided by 20. And finally, I get an average grade of 96 for the class. So notice how it's weighted towards 100, right? It's not in the middle. The middle between 80 and 100 would be 90. But it's way closer to 100 because way more students scored really well. So now you can also look at this as the weight times the data plus the weight times the data plus the weight times the data divided by the sum of the weights. So number 3 is a typical kind of class where they have different assessments given different weights. And I'm looking through them now. Papers 20% and a final project 20%. So these are the weights for the different assessment items. Now his scores for each of the categories were as follows. Test, he had an average of 85. So the weight, I'm going to use 40% times the data, which was 85, plus quizzes were 100. He got 100%. They're worth 20%, so that's the weight is 20% times the data, which is 100, plus 92 on papers, which is worth 20%. So the weight is 20% times 92. Just period 92. Plus the weight would be final project 20% times the data, which he got an 84. And then I'm going to get all that and divide that by the sum of the weights, which will be 40, 50, 60, 70, 80, 90, 100, which makes sense, right? Although you can get a partial grade. So I'm going to put this in our calculator, and you can do it yourself and see what you come up with. Now, one thing that students sometimes do is get the weights, which are the 40, the 20, the 20, and the 20, confused with the data, which is the 85, the 100, the 92, and the 84. And then they add up the data and divide by the data, which would make this a really big number. But if you do that, you should realize when you get an answer that the answer makes absolutely no sense in the world and is a result of you flipping the weights and the data. So let's put that in our calculators. And I'm getting an 89.2 for his overall grade. You might want to ask for extra credit, so close to an A, right? So let's look at number 4. So a company manufactures a product that takes the hours and costs determined below. Determine the average hourly wage to make this product. Okay, so it takes 8 hours of skilled labor, and skilled labor costs 28, 11 hours of semi-skilled, and semi-skilled is paid 21, and it takes 18 hours of unskilled, which takes 14. Now you cannot do this. This is the kiss of death. Add these up and divide by 3. Because really you need, if you wanted to do it the long way, you could take 28 8 times, right? Because it takes 8 hours. You could take 21 11 times and 14 18 times, which is essentially what we're going to do. Because it's the weight times the data plus the weight times the data plus the weight times the data divided by the sum of the weights. So these are the weights. If you get confused, I'll show you how you can check. So it's going to be 8 times $28 plus 11 times $21 plus 18 times $14 divided by the sum of the weights, which is right here, which is 37. And put this on our calculator, and I'll get $19.11. So that's the average hourly wage to make this product. Now, the only confusion you can get is you might say, well, what's the weights and what's the data? Notice 1911 is higher than the $14, which is the most amount of hours and the least cost per hour. And skilled is $28 an hour. Now, the average has got to fall somewhere between 14 and 28. It only makes sense, right? That should be logical. So what now if you made a mistake and instead of adding these up, you thought these were the weights? These would add up to 63 if you thought these were the weights here. So now I'm just going to put this back in my calculator with the wrong number of 63 and see what I get. And I get 1122. Well, it should be obvious that the average cannot be less than 14. So if you do a problem and you come up with a ridiculous answer, it's usually because you swapped out the weights and the data. You've got it backwards. So we're on problem 5. And you have the starting salary for 25 employees down here. 8 of them starting at $55,500 and 17 of them starting at $33,000. And you're trying to find the average starting salary for these employees. Now, because you have these numbers here, you should know now that you can't just add these two up and divide by 2. We have to do the weight times the average, or the weight times the data, plus the weight times the data, divided by the sum of the weights. It should be clear that the answer is going to be somewhere between 33,000 and 55,500. It's going to be not in the middle between these two, but it's going to be weighted towards the 17, so it'll be closer to 33,000 than 55,000. So let's do it. So we have 8 people times 55,500. That's their salary, plus the weight, which is now 17 times 33,000 divided by 25. If you added 55,000 and 33,000 and divided this by 88,000, you're going to get a starting salary of like $10 or something ridiculous. So look and watch. Does your answer make sense? And so let's put this in our calculator. And I'm getting 40,040. And that's the average starting salary. So our final question, number 6. So here's the grading scheme for a math class. You have all these different categories and all these different weights. And here is the grades you got for each one of the separate weights. So I'm going to do the data times the weight, or the weight times the data, doesn't matter. So I'll start out with the weights. 30% of my grade is based on a grade of 80. Plus 20% of my grade is based on a grade of 70. Because projects are worth 20% and I got a 70% on the projects. Plus 30% of the weight of my grade, which is the quizzes. I got an 85. Plus 10% of my grade are based on the midterm, and I got an 80, or you got an 80. And finally, 10% of my grade is based on the final, and here is what makes this different. You haven't taken the final yet. But after you add all those up and divide it by the sum of the weights, which, what do you think the sum of the weights are going to be? You should know without adding them. 100%, right? You want to be able to get an A. So you want to ask the question, what do you need on the final in order to get an A for the class, which is a 90 or better? So the minimum would be here. So now, what's the next step? Yes, how about all this, all of this can be multiplied and added together. So let's do that. So when I multiplied and added everything together, I got 7150. Plus still my 10 times I don't know what my final grade will be, equals 90, and this is all divided by 100. So what's the easiest way now to solve this? Give it some thought, right? Now how about getting rid of the 100? So if I multiply both sides by 100, I can then just have 7150, because these cancel, plus 10 times x equals 9,000. Now what's the next step? How about subtracting 7150 from both sides? And I'm going to get 10x equals, and if you did it right, you would get 1850. Now I've divided both sides by 10. And what does all this mean? Any ideas? Assuming I didn't make a mistake, which I triple checked, what does this mean? Well, it means in order to get an A for the class, you would need to get 185 points on the final exam. I don't think that's happening. So let's go down and look at a B. But what's different? What am I going to do differently in this question? Well, one thing I'm going to say, I'm going to change this to an 80. Anything else? Can I start? I don't need to redo this, so I can leave that 7150 to start. I can divide both sides or multiply both sides by 100 to start. So the only thing that I really need to change is going to be, it's going to be 80 times 100 instead of 90 times 100. So I'm going to keep basically this, with just this number changing based upon the 80 here. Okay, so we know that this is the same. So we got 7150 plus 10x equals, and I'll do a little bit more to it, divide by 100, equals 80. Because that's what we're trying to get now. What do we need to get on our final exam in order to get an 80 for the class? Multiply both sides by 100 and subtract 7150, correct? So we're going to get 10x equals 8,000 minus 7150. And I'm getting 850 divided by 10, divided by 10, and I have to get an 85 or better on the final exam in order to get a B for the class. Now a C, I'm going to speed it up a little bit for a C and a D. I need to get 70 or better here. So if I just change that to 70, that'll change that to 7,000. And let's look at that one. So far we determined we can't get an A and you need an 85% or better on the final to get a B. For a C, you need a 70% in the course. So it's the same algorithm with this changed to 70. That's all over 100. So we know that all of this is 7150. So let's just do, we have our 10 times what do we need on our final equals, and that's going to be 7,000 because I'm multiplying both sides by 100. And then I'm going to subtract 7150. So we get 10x equals negative 150, and you think you made a mistake. But let's look at this. You didn't make a mistake. All these multiplied together equals 7150. And then we're adding 10% of our final exam. And you want to get a grade, a final grade of a 70. Now think about this. What if you got a 0 on a final exam? Right? What if you got a 0? This is, of course, over 100. What if you got a 0 on the final exam? It wouldn't matter, because you're going to get a C no matter what. So it doesn't matter. You can not even take it. And the same for here. So the worst you can do in this class by not taking the final exam is to get a C. And the best you can do in this class is to get an 85 or better on the final exam in order to get a B. And you have these what-if scenarios in Canvas that you can look at also. There's no sense of doing a D because that'll just change this, and you'll have even a larger negative number.